In this class, we're going to take a look at how you solve inequations. So an inequation is solved similarly to an equation with only one or two kind of minor quirks, which we'll either look at in this class or maybe in the next class on inequations. The first thing is, of course, to figure out what is an inequation compared to an equation. Well, whereas an equation, for example, 2x equals 12, expresses equal quantities, so this is equal to this. An inequation expresses quantities which are either greater than or less than the other quantity. So in this case here, we're saying that this, the left-hand side of the equation, is equal to the right-hand side. And then we just do some algebra to solve for the x value. So dividing both sides by 2, we get x is equal to 6. So notice that with an equation, obviously this is a very basic equation, with an equation you get one solution. X is equal to that one solution for this type of linear equation. When you solve an inequation, we'll see in a moment, you don't get a solution, you get a whole range of values of solutions. So x is bigger than some number, smaller than some number. So say for example, x came out to be bigger than 4, then that means that it could be 5, could be 5.1, could be 7, could be 1,000,000, so it's a whole range of values. So that's one of the fundamental differences between an equation and an inequation. So I'm assuming in this class you're already familiar with solving equations, so we're going to kind of use solving equations as the basis for solving these inequations. You might not be familiar with the symbol though. If this is kind of new to you, or brand new to you, then you'll maybe never, well, you will never have seen that before. So let's start with some number examples just to get the symbol down. So whereas with equations, obviously we could say something, well, something kind of trivial like 10 equals 10, obviously they're equal. With inequations, we could say 10 is greater than 8 by writing it with a symbol like this. You could read inequations left to right or right to left. We usually read them left to right. So reading this guy left to right, we would say 10 is greater than 8. Reading it right to left, we would say 8 is less than 10. So the sharp end is the less than part, and the wide end, the open end, is the greater than part. If we introduce a variable, say x is greater than 8, that means that x has to be, we call it strictly greater than 8. So it's not allowed to include 8. Could be 8.1, could be 8.001, anything bigger than 8 but not 8 itself. So we say that x is equal to, for example, 8.1, it could be 9, it could be 12, it could be 1,000, any number, a whole range of values, every number in fact, bigger than 8. If, however, we make it greater than or equal to, which is another variation on the symbol, so putting the line underneath, that means that x is now allowed to be 8. So we could include 8 in our list of numbers. So strictly greater than or equal to. And then of course we can just write the symbol round the other way. You'll see it written both ways. So writing it the other way, we could have, for example, 7 is less than 12. But again, you can read that right to left if you wish, as 12 is greater than 7. Introducing a variable, you could have x is less than 12, x is strictly less than 12, or x is less than or equal to 12. So in your inequation questions, you'll see variations. So the symbol might be strictly greater than or less than, or it could be greater than or equal to, or less than or equal to. It doesn't really matter what the symbol is. We just keep the same symbol all the way through. So you'll never change this. One of the common mistakes, the biggest mistakes I see with students starting these, is that you go through the working, maybe correctly, and then at the end turn it into an equals to say that x equals something. That's understandable because you've probably already done a bunch of equations, but with these guys it's never equal. The solution to these inequations is not a value like it is with an equation, it's a range of values. So we want to say that this is satisfied when x is bigger than something or smaller than something, in the same way that an equation is satisfied when x equals some particular number. Okay, right, so let's take a look at how we actually go about solving these. The process really is just like an equation. We're going to gather all the x terms on one side, all the number terms on the other side, and then usually divide at the end. Like an equation, it doesn't matter if you take your x's to the left or to the right. I would say with these, the bigger rule, the thing you want to keep an eye on, more so than an equation, is trying to keep your x term positive. So we run into trouble when we've got a negative x coefficient of the x in these questions. I'm going to deal with that in the next class. So in this class, we're going to avoid that situation. But what we're going to do to avoid it is gather the x's on the side of the equation or inequation that it keeps them positive. So with equations, we usually keep the x's on the left, but not always. Sometimes we take them to the right, and we try and keep the x term positive there as well. But with these ones, definitely keep it positive if you can. There is a way to get around it if you don't, and like I said, we'll look at that in the next class. So just starting with this guy, we're going to gather all the x's on the left. So we're gathering them on the left. That is keeping it positive anyway, so that's fine. We're going to move the -4 to the right, so it works just like an equation. That will become a +4. So 6 plus 4. So we've got 2x is greater than 6 plus 4 is 10. Just the same thing as an equation, divide both sides by 2, and we get x is greater than 5. And that is a solution to that inequation. So that is saying that for all values where x is strictly greater than 5, this inequation would be satisfied. In other words, for all the x's greater than 5, 2x minus 4 is going to be greater than 6. And you can kind of see that, because if you take an x value bigger than 5, like 7, 2 times 7 is 14, minus 4 is 10, 10 is greater than 6. That's basically what the solution to an inequation represents. Okay, so that's kind of an entry-level question. We'll move up to these more challenging ones, but it's just the same idea. We're going to gather all the x's on the left here and the numbers on the right. So taking the 2x over, we would get 4x minus 2x is less than, or equal to, so a different symbol this time, but just pulling that symbol all the way down. 9 plus 1, so changing the -1 to a +1. 4x minus 2x is going to leave us with 2x is less than or equal to 10. Dividing both sides by 2, x is less than or equal to 5. So that means that x could be equal to 5 or any number smaller than 5. So if it was whole numbers, it would be 4, 3, 2, 1, etc. But generally we're not thinking only in whole number terms, so x could be 4.99, it could be 4.7, it could be any number, basically 5 or less. And that would carry on forever. So you get an infinite number of solutions to these, they carry on forever. Okay, cool, so that gives us the idea. Let's have a look at this one. It's got a bracket in it. It doesn't really matter though. Like equations with brackets, we just start by removing the bracket and then just taking the normal process from there. So 3 multiplies into the bracket, so we're going to get 3x, and then 3 times -4 to give us -12. This time I'm going to take the x's to that side to keep the x term positive. So we're going to have 3x minus 2x over here, and we're going to have 8 plus 12 over here. So 8 plus 12 is 20. So that's greater than or equal to 3x minus 2x is just x, and that's us basically done, because there's no division here because it went all the way straight to 1x, so that was quite fortunate. Usually in this scenario we would rewrite it with the x spun around to the left. Just be careful with these, because if that was, say for example, an equation, if you ended up with your x on the right in an equation and we spin it around, it doesn't really, well, there's no change in the direction of the sign there, because that sign is the same left to right and right to left, but this one's different. So if you do decide to pull your x to the left, be sure to keep it with the sharp end. So in other words, the sign would need to go like that. So x is less than or equal to 20, being read right to left on that line, and x is less than or equal to 20, reading it left to right on this line. So quite a common mistake in these questions is to get to this point and to do all of this work in like perfectly, and then to make the silly trivial mistake of swapping these around but not swapping the sign around, which is because you've probably learned how to do that with equations and you don't need to do anything with the sign on an equation. So a few little things to consider there that are slightly different between an equation and an inequation, but in terms of the algebra, gathering the terms together, usually dividing at the end, multiplying out brackets, all of that kind of algebraic steps are pretty much identical. The only quirk that comes into these really that you've got to be aware of is when you end up with a negative number here. So if that was like -2, we're not going to look at that in this class, but check out the next class where I'm going to talk about that situation. You can avoid that situation just by making sure you gather your terms on the side of the inequation like we did here to keep them positive, but it's good to know what you need to do if there is a negative there. So check that out in the next class. Make sure all of this makes sense to you. If it does, then maybe try a few practice questions, and then when you're ready, move on.